Well, this video, back in the science cave again, we're going to talk about everybody's favorite, it seems like, and that's the black hole. So we're going to look at black holes here. If I can get my pen going, there we go. So we'll look at black holes. Well, when you look at a black hole, you know, we looked at the life cycle of our sun here in the above one. Remember, it came from a bunch of gas and dust condensed under gravity, became high pressure, and you had that ignition, so to speak, of a nuclear fusion. Two hydrogens go into a helium with some of the mass converted to pure energy. Well, this is pretty much the life cycle. Red giant, planetary nebula, white dwarf, then a black or brown dwarf. Well, for a black hole to take place, you've got to have these stars a whole lot more mass. And quite often you need something that's about 20 times more than the mass of the sun. And so you're looking at really a very, very, very high mass star. And so, a black hole is a spot in space that light cannot get out. So light cannot escape. If you go back and remember our light, we didn't touch on it a lot, but light is a wave and a particle. And if it's a particle, well, if it's a particle, it's going to have some mass, and therefore gravity will affect it. Because no light gets out, you can't see these things. They're invisible. And you need special types of telescopes to catch these. So you have these giant stars, and when they go through the whole idea of, the fuel runs out, the pressure inside gets greater than the pressure pulling it in. You've got more pushing out than you've got pushing in. Instead of just having a planetary nebula where there's kind of a slough off their axis, they actually explode into what's called a supernova. And then from there, you get two possibilities: a neutron star or the ever famous black hole. Black holes can be big or small, and they can be very large also. And when you start, as soon as you can't see these, really how they found these is really due to their strong gravitational field. So black holes have strong gravitational fields. Now we're not going to get into how, really some of the nitty-gritty science on this. But let's just suffice it to say that they have a very, very strong gravitational fields here. And let's go over here once. Let's look at some maybe some facts on black holes here. Uh, Black holes, again, can be very, very large, and at the center of our galaxy, there's a black hole. So the Milky Way, and we'll look at the Milky Way in a little next video. The Milky Way has a black hole at the center. As a black hole, and we'll look at that in the next video. Uh, Scientists think how many of the black holes form when a star falls upon itself or collapses. So a star, oops, there we go, collapses. A star collapses on itself. And what ends up happening, you have a very, very bright supernova when this happens. So when it collapses on itself, then you get a supernova. Oh, that didn't work out too good. Let's try this again. Supernova. And this is an exploding star. When you have supernova, you have an exploding star. Exploding star. And this, well, what ends up happening after it explodes, you're left with the black holes. After the exploding star, you're left with the black hole. So you go back to our little diagram here. So after all this material falls in on itself, you have this great explosion, and then you have this black hole. Black hole cannot be seen because of the strong gravity that pulls light back into the middle of the black hole. Scientists see it because there's a gravitational field around it, and it affects how light interacts with that gravitational field, and scientists can see that interaction. Uh, there's always a question, can black holes destroy the Earth? Well, they don't go around, eating stars, moon, and planets. For one thing, there's not a black hole near us, so we're not going to have to worry about that. Black holes are, really kind of interesting. I've got some, if you go into the resources, there's some more stuff on black holes there. But it's interesting, you get these, let's see, okay. And you get these super massive black holes. And what ends up happening is everything gets sucked into them. Their gravitational field's so strong that any material getting near the edge and will get sucked into it. Now the edge of a black hole, and you will not be tested on this, but the edge of a black hole is called the event horizon. The edge of a black hole. And that would be, all right, there is the event horizon. If you read all other astronomy stuff, some people, scientists say, oh, there's wormholes, and if you get into it, you come out the other side. There's all sorts of good stuff on there, and it's a little bit beyond the scope of this class. Get in there into some of that, the math would start to get a little on the tricky side. But suffice it to say that it's got such a strong gravitational field that nothing can escape it. So that's probably the key thing of this part to remember. All right, so we'll wrap this one up, and we've got one more in this series.